everybody. I'm super excited to be here today. Thank you very much to the Society for inviting me all the way from the beautiful tropical island of Sri Lanka. I'm really excited to be able to share a little bit about my conservation journey, working with an incredible population of blue whales that live around my island home. I'm going to start my story by taking you back in time to 2003. At this time in my career, which was really at the very start, I was working on a whale research vessel that was circumnavigating the globe. I happened to be working on it in the Maldives and Sri Lanka, so in the northern Indian Ocean. And I had this amazing encounter that actually really shifted my life story and sort of created my career. On this particular day of significance, we were off the southeast coast of Sri Lanka. It was a beautiful, flat, calm day, not a drop of wind. And you can see that from this photograph. It was just an amazing day to be out there. What we were doing was we were tracking sperm whales. So we dropped these underwater microphones or hydrophones into the water and eavesdrop on their conversations, find them, get up to them, and then take these tiny biopsy samples that could tell us all these stories about the toxicology of the ocean environment. I knew what I was looking for because I'd spent some weeks already tracking sperm whales. A low, bushy blow slanted off onto the left hand side. Because while all marine mammals do come up to the surface to breathe, they have blowholes, and sperm whales have one blowhole, but it's located on the left hand side of their head. So it's quite a characteristic blow when we see it. So we were out there, and on these expeditions, it's not just doing the acoustic work, but we always have someone up on deck looking out for signs of life during the daylight hours. So on this day, I was out there. I was staring out to sea. I was looking for these sperm whales. I could hear that chatter. It was such a cacophony. And the sounds were being played on loudspeaker inside our pilot house. It was emanating through the floors, rising up to where I was. And I could hear them, and I knew they were out there. I knew I wanted to be the one to see them that day and to locate them. And so here I was standing, staring in the sun in this sweltering heat. And I was getting increasingly frustrated because I could not find them. The ocean is so vast, and we often think about it as this big blue tank of water when nothing else is happening because we can't see it. But the world underneath is rich, and that's a fact. But that's also the tricky part about the work I do, is that we don't often get to see things constantly. A lot of it is a waiting game. That was my first big lesson on this expedition. So we're out there, and I'm about to give up because my shift is coming to an end. And then that's when I saw this. A tall, powerful, vertical blow that rose, as far as I could tell, all the way to the sky. It was so tall and powerful, I knew it could only have been produced by a creature that was gigantic. So I got really excited at this point, and I grabbed the walkie-talkie that was dangling in front of me. I, called down to my captain. I said, Bob, we have to go 11 o'clock, 2 kilometers, move. And he goes, why? And I say, I think it's a blue whale. And he says, fine. And he turns the course of the ship in the direction of that I've just told him to go in. And please note at this point, I was just the deckhand on this boat. I was cleaning toilets and polishing brass. So not a very significant role, but I appreciate the trust he put in me. And we start moving in this direction. And as we start moving closer and closer, I'm so afraid that I'm going to lose sight of this animal. And I'm staring, and there's tears streaming down my face. And I'm determined not to lose sight. And that's when I start to think I'm losing my mind. Because it wasn't just one blue whale I was seeing. There were 6 blue whales in an area the size of a football field or a soccer pitch. At that point, I thought, what on earth is happening, right? Like, these are the largest animals to ever roam our planet. They have the freedom to really roam 70% of the planet if they wanted to. And I could not for the life of me figure out why they would aggregate in this small area. Each animal is the length of a basketball court. So I was fresh out of undergrad, so obviously I had all the answers, and I reflected back on what my professors and textbooks had said, and I remembered, right? They said, Large whales, like blue whales, undertake long range migrations between cold feeding areas and warm breeding and calving areas. Sri Lanka is 5 degrees above the equator. It's as warm and tropical as you can get. And I thought to myself, that's it. I'm going to be the first person to ever document blue whales mating. So I was really excited, needless to say, and I think anyone in my position would have been excited. And so I encouraged Bob to move faster and move, because I want to get there before this whole thing ends. And I'm like, let's go, let's go. And we're moving faster and getting closer and closer and closer and closer and closer. And then finally we get there, and it is not at all what I expected to see. There was definitely no mating going on. There were no calves. In fact, the whales were kind of just lolling about. One would just hang out on the surface, another one would very casually just dive down, come back up, right? Like there's this process, but nothing felt exhilarating. I mean, I was excited because I was seeing these blue whales and they were, there, and this is the largest animals to roam the planet, but they weren't doing what I expected them to do. And so anyway, I sidle up to Bob and I say, Bob, do you think we can hang around a little bit? Partly because I felt guilty that I'd taken them off course. And he says, okay, fine. And I'm super, super glad we did. Because that's when I saw this. This, ladies and gentlemen, is a pile of blue whale poop. Not only is it the most beautiful poop in the animal kingdom, and I always challenge people at this point. I say, look, if you think you've ever seen more beautiful animal poop, do send in a photograph. But apart from that, this byproduct, this thing that most people would turn their nose up to, was actually my eureka moment. Because when I saw this poop, I realized that if the animals were pooping, that means they were feeding somewhere close. But remember what I said earlier. I said large whales undertake these long migrations between cold feeding areas and warm breeding and calving areas. But by seeing this poop here, 5 degrees above the equator in the most tropical waters, I realized that this particular population of blue whales was doing something different. Not everyone can say that their career started with a pile of poop, but mine did, and I'm really excited about it. That's where it all began for me. And in the intervening years, obviously, I've done a bunch of work. I have, had the privilege to spend a lot of time side by side with these giants in these tropical oceans. We have discovered many things, like, for example, that they're the only non-migratory population of blue whales in the world. They tend to spend all their time in these warm tropical areas. Their range is pretty small, so they'll go off to the east coast of Sri Lanka, maybe down to the Maldives, off to maybe Somalia, like the Arabian Sea, but that really is their limited range, which is super unusual for an animal that gigantic. Apart from that, they also have a unique vocal dialect. So if I took a blue whale from Sri Lanka by some magic means and dropped it in the ocean, say off California, the blue whales wouldn't be able to communicate. They might be the same species, but they have different dialects. We also know that they lift their tail flukes up before a deep dive more often than anywhere else in the world. It's a photographer's dream out here. They will lift their tail flukes up about 60% of the time, whereas in other places across the world, it's less than 15% of the time. So this was something that obviously intrigued me for a long time. I was like super curious about why they would do this. It's an energetically demanding thing to lift your entire body and then, kind of sink to the depths of the ocean. And so further research into their diet actually showed us that the key thing, and please note, for the dietary studies, we used poop. So it is really a magical substance. While if you Google, what do blue whales eat, the internet will basically tell you they all eat krill. What's unique about this population, on top of everything else, is that these guys feed on a type of shrimp. So it's super interesting because the shrimp is found deeper in the water column, which means these whales have to dive deeper, which therefore makes sense why they lift their tail flukes up and torpedo themselves to these depths. So it's been like building a jigsaw puzzle, right? But the key thing is, these questions aren't just frivolous. They're not just for the sake of asking questions. I ask these questions because I do want to figure out how best to protect these populations. And while I would say that none of the countries in this northern Indian Ocean region where these animals roam have ever indulged in whaling, in the 60s, there was illegal Soviet whaling. So, where the Soviets would basically traverse through these waters and go down to Antarctica to hunt whales. And at one point, they realized, well, there are blue whales in this ocean basin too. Let's take a couple out, right? And they did. They took out 1,294 in a period of, we say, 4 seasons. Each season was less than a month, maybe. So, a really short time, they took out a really large number. And potentially, this has had an impact on the population, and that's definitely something we're trying to figure out. But today, whaling is not the biggest threat to whales anywhere in the world. There are lots of other significant threats that come together to compound the problems that these animals have to face. Out here in Sri Lanka, the biggest threat that they face is ship strike. So this is a typical scene on the water in Sri Lanka. You'll see a beautiful blue whale diving to the depths, and in the background you see a ship. So these animals are constantly weaving through a pretty busy shipping highway. Let's take a look at some of the global ship traffic data actually that's available out there. And from this map, I mean, there's loads of noodles, right? So like, don't stress yourself out over it. Just focus on the yellow lines. The yellow lines indicate the busiest shipping routes in the world. And if we zoom into the area of interest, which is also the range of this particular population of blue whales, you can see that the southern coast of Sri Lanka is on the path of one of the busiest shipping highways in the world. Basically, it's the main artery through the Indian Ocean. Everything from, say, Dubai to Singapore to huge ports travels through this area. While global ship traffic has doubled since the 70s, it's quadrupled in this part of the world because the way trade is moving has changed. And that means as shipping increases, which it is projected to do, we're going to see more ships on the water, and of course, lots of other things. And at this point, the most important thing to point out is that I'm not saying that there's a problem with shipping. I'm saying we are all part of the problem. 90% of everything is shipped, right? So for that reason, I think it's important that we all acknowledge that there's this problem, but we also work to become part of the solution. So here's just some of the data that we've collected. And you can see here, it's a map of actual ship movement data. So we get it from AIS, Automatic Identification System data. You can see the red lines are like the very busy shipping lanes on these coastlines. The black dots are where we've done a lot of work and seen blue whales, documented blue whales. What should be immediately obvious is that on the south coast of Sri Lanka, there is distinct overlap between where we're seeing the whales and where we're seeing the ships. So sites like this are not necessarily a surprise. This is a blue whale that came into our main harbor in Sri Lanka, wrapped on the bow of a container ship. We know the animal died on impact because it showed signs of internal hemorrhaging. The carcass is quite fresh. Just a couple of weeks later, we found another carcass floating at sea with a massive propeller gash, indicative of ship strike. Now, the issue for us is often that evidence of this nature doesn't always exist. Blue whale carcasses are negatively buoyant, so if they get hit at sea, quite often the carcasses will sink. So we don't get evidence of what animals that die or also how many died. And that can be a disadvantage because the first question people always ask me is, okay, but how many are dying from ship strike, right? And it's really, really hard for us to say. If a carcass washes up onto our beaches, it's very tropical here, it's hot, it's humid. These carcasses can deteriorate very fast. So it's hard to find evidence also of ship strike. Unless it's a fresh carcass, it's washed up and we can do necropsies to tell the story. But this is a fine example of the fact that it's happening. And if we look at some of the other parts of the world, for example, California has a similar problem, and they've done extensive research on ship strike issues out there. They've found that for every individual that gets documented getting hit by ships, there's at least 10 others that go undocumented. So it's not a small number, it's not insignificant, and it's something that's actually a growing problem as we get more ships out on the ocean. It's a numbers game, right? I believe that this problem is also incredibly resolvable. Conservation is a very complicated beast. Oftentimes, there's multiple facets, and you have to tease things out and to try to figure out how to resolve the problems. But in this case, you can simplify it. If we can identify where the whales and the ships are and where they overlap, if we can like separate that overlap, then we should be able to come up with some resolution. And so my work has really focused on that for the last 9 years, trying to come up with recommendations for what we can do better so that we can coexist with these species, and actually continue to live the lives we do and fulfill our needs in a more sustainable manner. So our recommendation is that, based on science, is that if we shift the shipping lanes on the southern coast of Sri Lanka by 20 nautical miles, we can reduce the ship strike by 80%. This is significant, mostly because actually 90% of the vessels traversing through this area are just bypassing the country. They're not actually coming into Sri Lanka, so we're not benefiting from them economically in any way. Not only will this be beneficial to the whales, but with conservation, it's also about considering the entire ecosystem and all the stakeholders that are involved. By shifting these shipping lanes further out, we'll also create safer spaces for the whale watch industry. So in this image, you can see there's a container ship, there's a blue whale, but there's also a tiny little whale watch boat in the corner. This is a real scene. So we can increase safety for the whale watch operators. We can increase safety for the small scale fisher people who work in these areas, because most of our fisheries are actually small scale and coastal. And also we can uphold some of the sort of the global policies that we've signed up to, for in this case, where we reduce ship-based pollution to coastal populations. The 10% of vessels that are coming into our ports, well, if they slow down over certain areas, we could actually reduce the risk of lethal ship strike. Science has shown that below certain speeds, that ship strike can be less lethal. The problem in that image that I showed you with the whale raptor on the bow of the container ship was that the vessel was going incredibly fast through that area. So the animal had absolutely no chance at all. So I hope you realize that there are ways to look at problems, but it's also important for us to think about conservation, not just as research, not just as producing a publication, but really taking it into the space of impact, but also considering not just a single species, but also the entire ecosystem, because there have to be multiple wins if we want to make a difference. But in all the work I do, a lot of people come to me and they say, oh, why do you do this work, right? Like, it seems grueling. You spend hours at sea just staring out for signs of life, which is absolutely true. This is kind of a typical scene as well. And what is it that drives you? Is it because these animals are charismatic and beautiful? And I say, yeah, absolutely. These animals are magnificent, charismatic, beautiful. And when I'm out there, I remind myself all the time, I am here living side by side with the largest animal that has ever roamed the ocean, right? Like, what an absolute privilege. But if I stopped there, if that was the only driving factor for my work and my desire to protect them, it would be a bit lame. I'd be doing them a disservice. Because these animals are actually what we call ecosystem engineers. Their presence in the ecosystem allows the proper functioning of all the different parts that happen around them. Let me give you an example. Whales dive to the depths to feed. They feed in areas where there are nutrients that you don't get that are actually in limited supply at the surface of the ocean. So when they go down there, they feast on their favorite food, and then they also consume these nutrients that then, when they come up to the surface to breathe, they release these giant fecal plumes. These giant fecal plumes are now chock full of those nutrients. This is the ocean's fertilizer. So basically, what happens then is this fertilizer basically is used up by phytoplankton, the tiny microscopic plants that float all over our ocean surface. These phytoplankton feast on that and sunshine in the morning, and then they photosynthesize and they release oxygen to the environment. 50 to 70% of the oxygen that we breathe is actually generated by plants in the ocean, and clearly some proportion is fertilized by whale poop. And also, the more phytoplankton there is in the oceans, the better it is, because that is the base of every single marine food chain. And obviously, if there's more phytoplankton, there's more things that eat the phytoplankton, and so on and so forth. So obviously, this is a really valuable service. Apart from that, even in their death, blue whales or any whale provide really important services. Their carcasses are the largest form of detritus to sink from the ocean surface to the floor of the ocean. All the way, they feed about 400 different species of creatures that are dependent on these carcasses for their survival. And so you can see here, at the surface, there's all these seabirds, there's some sharks going for this carcass, but after a while, it'll start to sink deeper. They provide food to even these things like these slimy, ugly hagfish. And it's important because they also, as their carcasses sink, they trap carbon in their bodies and take them down to the depths of the oceans. The ocean is the largest carbon sink in the world. And this carbon sink, by trapping that excess carbon from the atmosphere, what happens is it's actually helping us to buffer these extreme impacts of climate change. So the ocean is a very, very important way of actually mitigating the worst effects of climate change. But we also seem to be kind of pushing our luck at the moment. And then on a very personal level, right? So that's one reason why I care for these species and why I dedicate my life to them. But also there's usually some other personal story. So some of my work involves actually getting out there and using a very simple tool, a camera, to do what we call photo identification. We take photographs of particular parts of a whale and look for characteristic long-term markings that can help us to identify and re-identify individuals over and over again. So in the case of blue whales, we'll use their tail flukes and their dorsal sides, and you can see very different marking patterns. In 2011, I was involved in a documentary shoot off the east coast of the island, and I was out there and I took this photograph of this tail fluke. It was beautiful. You can see some really characteristic markings, like the heart shape, for example. And as soon as I saw it, I thought, I've seen this animal before. Now, what I should point out is that before I did this work, there was 30 years before that, an expedition had come through and done written probably 2 publications about this blue whale population. They were very, very, very little known. And actually, my work is the first long-term research on these blue whales in the northern Indian Ocean. So I went back to one of these publications where I knew there were some photographs, and I found this, right? I mean, I hope you can see why it's so exciting, right? You can see in 1984, we've cited that same whale. Someone's taken that photograph, very characteristic heart-shaped marking, but we usually use about 3 markings, and we can confirm it's the same individual 27 years later. This is now known as the oldest known blue whale in this population, in this region, the northern Indian Ocean, which is really, really quite magnificent. I've named it Whalentine for very obvious and probably fairly cliche reasons. But the cool thing is that, we can start to build stories and understand the demographics of these populations as a result of this very simple tool. And what's even cooler is that where I saw this whale in 2011 was just about 10 kilometers away from where it was seen in 1984. So work like this can also help us to hone in on areas that are important to these species, help us to understand where we need to focus our attention and where we need to work harder to put into place protection measures. So through my work, I've learned loads of things, right? The ocean is a great teacher. But apart from that, one thing I do want to add at this point is it's not been a straightforward journey. It hasn't certainly been easy. And one of the key things I learned very early on in my career was this idea of colonial science or parachute science. And give me a second, I do want to talk about this. And I think it's incredibly important that we all start to think about this and the problem it poses. So I told you how I made that discovery, and I saw these whales and they were pooping, and evidently they were doing something different, and they basically weren't doing what the textbooks were telling us, right? They were hanging out in warm tropical waters throughout their lives. As soon as I had this sighting, I tried to do some research. There was little material available. And so I reached out to some experts in the field, people who had dedicated their time and lives to working with blue whales. And I said, look, I've discovered this thing and I'm really excited. I'd like to establish some research around it. Can you help me? And I got lots of enthusiastic replies, but mostly they just kept saying, this is amazing. Can you get us a research permit so we can bring our teams out and do the work? That was the first time I realized that the culture of conservation depended heavily on the Western world believing that there was a lack of capacity and ability in the global South, in the developing world. I was adamant I was not going to let that happen. So it took me 5 years to actually establish the Sri Lankan Blue Whale project because I was going to do it on my own. It was a homegrown project, and I wanted to show the world that it was possible. This is something that's prevalent. So colonial science is when outsiders, Western scientists come into these exotic developing countries and do work without any investment in infrastructure or in capacity, and then they leave and do all the publications and get all the glory for the work. But what happens there is it cripples conservation efforts that are already existing on the ground. The unequal partnerships create a very, very unhealthy imbalance, and this is hugely problematic for the movement of conservation, the protection of these ecosystems that we claim to want to work for. And this COVID-19 situation has been really important in reminding us of the absolute issue with this problem. I've been listening to people saying, oh my gosh, I have a huge gap in my data set right now because I can't get out to such and such a place. And I keep reminding them, I said, well, if you'd invested in your local partners, if you guys had an equal partnership, if you had worked together to identify the problem and then work together to figure out how you do the work, you would have zero gaps in your data set. And so, in this audience, I have no doubt there are established researchers, but there are people moving into this field. I want you to think about the fact that working anywhere outside your home is an absolute privilege, and it is not a right. So we all have to do better at making sure that our work isn't colonial, isn't a parachute model. Because certainly in marine conservation, as I always say, if we truly want to save our oceans, every coastline needs a local hero. I'm just going to run a quick little video so you can get a sense of my organization. With that, I want to say thank you very much. I hope you enjoy the rest of the conference, and I look forward to engaging with all of you at some point. Thank you.